Okay, we're doing homework covering non-parametric tests. So question number 1, we need to find out which one of them, of these tests, have requirement about nature or shape the population involved. That is the parametric one, because non-parametric does not require. Okay. Next one. Which of the following is not an advantage of non-parametric methods? Well, let's go one by one. Non-parametric methods can often be applied to categorical data such as gender of survey respondent. This is true. Okay. Next one, non-parametric methods can be applied to a wide variety of situations because they do not have more rigid requirements of the corresponding parametric method. This is also true. Non-parametric, third one, C, non-parametric methods do not require normally distributed population. Very true. And the last one, non-parametric methods are more efficient than parametric method. Now this one is just not true because they don't have any specific requirement, and you can use into any free types of distribution. They are less efficient usually. Okay. Question number 3. What do we have next? What do we have here? Rank, sort, position, placement, score is a number assigned to an individual sample item according to its order. So from the lecture, whoever watched the lecture already knows that that's a rank in a sorting, in ascending order or sorted order. All right. So check the answer. We are good. Doing next one. We are given data here. So weights were measured from college students in September and later in April of their freshman year. The measurements are listed in the pop-up table below. Okay, here are measurements. Assume that we plan to use the science test to test the claim of no difference between September and April. Okay, let me look one more time. 67, 66, 53, 52. Not significance level at all. They are very close. Most of this data. All right. What requirement must be satisfied for this test? Is there any requirement that the population must have normal distribution or any other specific distribution? Is there sense? Is in what sense this science test a distribution-free test? Okay, let's go one by one. See what we have. The matched pairs must constitute a simple random sample that approximately follow normal distribution. This is just not true because it's a free distribution-free test, science test. Therefore, with matched pairs, therefore cannot be A. B, the matched pair must constitute a simple random sample. This one does match, but let's go other ones also. Maybe we can find better case or both. It says both cases. We'll see. The matched pair must approximately follow normal distribution. That is not the case. There must be more than 30 matches pairs. That is not the case. Also, there must be more than 30 matched pairs that all constitute a simple. No, there is no limitation for 30 matched pairs. It's true that they have constitute simple random sample. That's why I said B is a correct answer, but there is no the requirement about amount of matched pairs. There must be more than 30. It's already baloney. We are moving on. There must be more than 30. Also moving on. None of these. No. So it is B. We are doing good job. Moving to next question. Number 4. No, we did this one. Oh, next one. We have another question here. Is there a requirement that population must have a normal distribution or any specific distribution? Well, I guess you already know that the Sion test and Wilcoxon test, they don't require any specific distribution. It can be any distribution. So which one is giving us normal distribution, not working, F distribution, student T, any, D. Okay, no requirement. Question number 5. More? Gee. Okay, and last question, I guess. In what sense is the Sion test is distribution free? Okay. A, the Sion test is distribution free in the sense that central limit, that's nonsense. The Sion test is distribution free in the sense that it doesn't require normal distribution or any specific distribution. That makes sense, absolutely. Okay, but still check others. The Sion test distribution free in the sense that there is no distribution to the, no, that's baloney. It has to have distribution, but any distribution. The Sion test is distribution free in the sense that researchers can use any distribution to find critical value. That is also not true. You can't get p-value for any distribution. It's a requirement. Okay. Fantastic. Moving to next fantastic answers. So what do we have? Listed below are cost in dollars of flights between two different airlines. Okay, use 0.05 significance level to test the claim that there is no difference in cost between flights scheduled 1 day in advance and those scheduled 30 days in advance. Well, from my experience, I can say there is a difference. The closer to the flight, the more expensive in life. Let's see what they are here saying. What appears to be a wise scheduling strategy? Okay. So step number 1, we need to find null and alternative hypothesis. So our claim is that they say that there is no difference between flight schedule on 1 day in advance or flight schedule 30 days in advance, right? So the claim is there is no difference, right? Test the claim that there is no difference. Okay, so our null hypothesis is going to be our claim. There is no difference. Median of the difference is 0. To remind you, since we are going to do a Sion test, non-parametric test, then we are going to test median. And there is a difference. The median of the difference is not equal 0. Why is it non-parametric? It doesn't say any the distribution, form of distribution. And here we are looking before and after kind of matched the samples, right? Paired samples. Therefore, we are using Sion test. So there is no difference and there is difference. Checking the answer. Bingo. Nice work. Next, we are going to use test statistics. How we are going to use test statistics? So first of all, we are looking at the difference. So we are going to take the difference between all these in 1 day advance, 30 days advance. So I'm going through and all differences are going to be positive, right? So our n is going to be how many? 7 total. is 7, out of which x is negative. It's going to be how many? 0. So my x is going to be 0 because we don't have any the negative difference. Yes? Okay, fantastic. Next, we need to find the critical value. So here is our critical value. So we are going to use our critical value for the science test table to find it. For two-tailed test, because we have two-tailed test 0.05 for two-tail, which is going to be here. I see 0.05 for two-tail, right? And our critical value, since how many we had total there? N was, let me see, 1, 2, 3, 4, 5, 6, 7 elements. So here we have 8, N is equal 8. But we don't have 7 because since the first line is all 0 for 0.05 to tail, that means 7 also going to be 0. Therefore, we're going to say that critical value for two tail 0.05 and n is equal 7. We had 7 and there was no difference equal 0 to subtract. Therefore, it's going to be 0. So from here, we are going to say that our critical value is also going to be 0. Okay, fantastic. So from here, what conclusion we are going to draw? Since our claim is null hypothesis, and if it's they are equal, right? So test statistics and critical value. So we are going to reject our null hypothesis. Yes? Why we are going to reject our null hypothesis? Because the number of less frequent sign, which is x, is less or equal to the critical value. So in our case, it's equal. Our x, that is a less frequent number, which is negative in our case, because all we have positive equals 7, and x is 0, negative. And it's either less or equal to critical. In our case, it's equal to 0. Therefore, we reject null hypothesis. And we are saying, since we reject, that means there is sufficient evidence to reject the claim. And then the best strategy seems to schedule your flight 30 days in advance. Why? Because if we reject null hypothesis, when we say there is no difference, which I was right from the very beginning. Remember, I said, I don't believe there is no difference. You buy earlier, you buy cheaper. You buy last minute, you pay the top price. Therefore, regarding alternative hypothesis, we say that it makes sense to schedule flight 30 days in advance. Okay. We are good. So did we check this one? I don't think so. And we move to question number 6. What do we have in question number 6? Assume that matched pairs of data from a poll of internet users who were asked if they make travel plans through the internet result in 328 positive sign, 282 negative sign, and 25 ties, which is 0 difference, ties when the value of the second variable is subtracted from the first corresponding value of the first one. We already understood that. So use the sign test with 0.05 significance level to test the null hypothesis of no difference. So what is going to be our null hypothesis? it's going to be, let me see, null hypothesis equal and our alternative is not equal, so it's going to be B, right? Okay. Next we are going to check this claim, right? It's equal or not equal. For the beginning we need to find the test statistics. Okay, first of all, we have, what do we have here? 328 positive sign from the word problem I'm reading, and 282 negative. So which one is less negative signs, right? That means x is gonna be 282, right? And let me see if I can write down. So 282 and 328. 282 and 328. So this is x, smallest number. I mean, the less frequent number, it's negative sign. Let me add 10, 11, 5, 610. Now, because it's greater than equal 25, we are going to approximate. That means the sample is so large that we can approximate to our z-score, okay, z-test. And we are going to calculate our z-test in this case, okay? So therefore, the formula for a z-test in this case, it's going to be x plus 0.5, remember? We had this formula, minus n over 2, n divided by square root n over 2. So what do we have? X is 282, right? And we are going adjusting plus 0.5. This is approximation of normal distribution, and minus n is 610 over 2 and divided by square root 610. This is our n. This is negative sign, this is positive sign. If we would have positive less, then I would take x as a less one, whichever is less frequency. 610 divided by 2. Okay. Now, and this is gonna give me, I need to figure it out, so let's do the math together. So first I'm going to do 610 by 2, this is gonna be 305, and 282 plus 05, 282 plus 5. So I'm going to get negative sign. So what do we get? 305 minus 282, it's gonna be 3, 2, 3, 2, negative 23, and 0.5 is negative 22 and 5, divided by square root of 610. 24 and 7, 0, I would say. 24 and 7, 0 divided by 2. This is going to be 22.5 divided by 1, 2, 3, 5. So 22.5 divided by 12.35, and we are getting negative. So this score is getting negative 1.82. Well, wish me good luck. Let me write down. Where is negative? Okay, I'll write down 1 point. No. 1.82, and here in front negative. Excellent. Okay, so we got that one also done, and we need to find test statistics into technology and find the p-value. Let's do it. So you are opening your z-score table, which is -1 because you have -1.82. Let me see, -1.82. I got 0.344. Let me do drafting. 0.344. Double check. 82 negative 0.0344. And since we have two tail, multiply by 2 because it's only for left tail. So it's going to be 88600. 0.0688. Let me see how many digital they want. 4. Okay. 0.0688. Nice work. Okay, we did good job. And lastly, we need to identify, does the null hypothesis of no difference hold? So we need to figure out if we have the null hypothesis is true or the alternative one is true. Now, what is going that we are going to do? We are going to take p-value and compare. Our alpha was 0.5, 0.05. Here it is in the word problem, 0.05, and our p-value is greater. So since the p-value is greater than significance level, what do? We fail to reject the null hypothesis of no difference. Why? Because it's 0.05 for that is for two tails, right? We divide by 2, 0.025, right? And it's falling in the healthy area, 0.0688. Therefore, we fail to reject the null hypothesis. Fail to reject p-values greater than significance level. We fail to reject, okay, it's B, of no difference. Okay, good job. Moving to question number 7. So what do we have here? Oh, entire table. Looks like we are going to go to crunch. We'll see. Use 0.05 significance level to test the claim that there is a significant difference between actual and reported height in inches. For 12 to 16 years old boys, the data listed in the table. Okay, so let mu1 denote the median of the first table and mu2 denote the median of the second table. What are the null and alternative hypotheses? So here, important keywords. There is a difference between actual and reported. So we choose null hypothesis, no difference, and then we choose difference. It's going to be C. Now we need to find test statistics. Okay? So what we're going to do for test statistics, I'm opening this data. I checked the StatCrunch. It won't give us test statistics in there. So whoever wants can do in Excel, right? I can't open Excel in iPad. So I just copied and pasted in my note. I'm going to open this so you can see. And I prepared, not to waste your time, I prepared the different, so we have to do reported minus actual. Reported minus actual, and not vice versa. And if it's positive, positive, if it's negative, negative. Now, total we have 30 elements. Here we have one the type 0. So it's going to be 30 minus 1, n is going to be 29, right? And x is going to be, as we can see here, negative signs is less than positive, so let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. X we have 10. Now, because n is 29, it's more than 25, then we can approximate, and it's close to 30, right, actually, so we can approximate to normal distribution. And because there is no n is equal 29 in the science test, right? Science rank table for 29. Therefore, we are going to use z-score calculation test statistics because it's approximating to normal distribution and it's more than 25. Therefore, you are going to, I'm not going to calculate, I just guide you and you can do it because it's the same calculation I already did as the previous one. So the critical is going to be x plus 0.5 minus n over 2 and divided by square root n over 2. Next, you are going to take this z-score, whatever you get. Let me put this a. So z-score of a, that is equal a, and you go to find in the table, get your p-value. If it's negative, it's gonna go to negative z-score. If it's positive, you're gonna go to, but most likely it's gonna be negative because tail, it's gonna, p-value is gonna be less than usually, or a small value, p-value, okay? Once you get it, you get this p-value, and once you have p-value, then you are going to decide for p-value method, we reject null hypothesis if p-value is less or equal our alpha. Then we reject null hypothesis. Okay, if p-value is greater alpha, then we fail to reject null hypothesis. Okay, so I guess I will open the answer instead of solving. I'll just see what it will say here, how much it will give me, and it doesn't give me the result. Okay, well, at least you know how you're gonna do it. No, it doesn't show me the result. So practically you have to get test statistics, and based on decision I gave you, you make this the decision if it's you're gonna fail to reject or reject. You can go back to question number 6 and exactly same way. So let me go back to number 7, exactly same way as 6. It's a similar question. So let me see, show. There we go, this time it showed. So if you want to try, this is a critical this is a database, and I had in the notes, so you can go by that and plug the values, calculate, and check yourself if you want to. But I am moving to question number 8. What do we have here? So, which of the following is not true when you sign tests with data that are matched pair? Since we already discussed this, so I'll just go straight to the correct answer, which one is not true. Record, let me go. Record ties with a positive sign when any matched pairs have both values that are equal. So this is just not true. It's going to be A. Exclude ties and throw out. That is very true. Subtract each value of the second variable from the corresponding. This is true. Record only the sign of the difference when subtracting values of the second variable from the corresponding is also true. So let's check. Good job. Question number 9. Let's see where we are heading. Question number 9. So we have any adults random selected for a poll were asked if they favor the opposed. Now we have big numbers again, so looks like again we're gonna do a z-test. So, all right. The politician claims that people don't really understand the stem cell issue, and their responses to such questions are random responses equivalent to a coin flip. Okay, so use 0.1 significant 10% significance level to test the claim that the proportion subject for response in favor is equal. So we are dealing with proportion, equal, not equal. That is gonna be D. Fantastic. Now, next we need to find out our z-score table. So how much do we have? We need to find what is our x, what is our n, and keep going. So 491 were in favor, right? And which is going to be 491, it's going to be with plus, write down, just like I wrote down. And 422 is going to be with minus. 422 is going to be with minus. So total it's going to be 491 plus 422. It's going to be 913. Our n is our n is going to be 913 in this example. So, and our x is going to be 422 because it is smaller. So n is 913, x is 422. And you are going to use the same, here it is, z-score table. So here let's clean, so you will have it. I will use it for our case. X is 422. 422, n is 913. So this is minus. Positive 1 is 492, 91. That is positive. If you add them up, these two, that will give you 913. So you plug to z-score, and you are going to get your p-value the same way, and based on what the p-value is greater or less alpha, you are going to reject or fail to reject. Okay, and that is gonna make our decision. So let me see if I can open the answers. Looks like it's not opening answers. Okay, never mind. I'll go ahead and solve it. So Let's calculate what we have. We are going to figure out our z-score by calculation, test statistics by calculation. Let's do it. So how much we have? Z is equal, our x is 422 plus 0.5 minus total amount 913 divided by 2 divided by square root of n, meaning square root of 913 divided by 2. Okay, this is equal 422.5 minus 913 by 2. 9 by 2 is 4, 11 by 2 is 5, 13 by 2 is 6, and 0.5. Okay, divided by square root. Now that one I can do in my mind. I'm going to use calculator. 913 square root. It's going to be 30.22. 30.22 divided by 2. So what do we get here? 456. Well, I'm dropping this 0.5 because both of them have 0.5. Minus 422. That's going to be 34. And 30 divided by 22, it's going to be 1, 15, and 1, 1. So 34 divided by 15.11, and it's negative actually, right? And we are getting, one more time, 34 divided by 15.11, I'm getting negative 2.25. Okay, so this is z statistics. Now this time seems to me, let me write down, it's negative 2.25. Negative 2.25. Okay, good job. This time it doesn't want p-value, it wants z critical. So if we need to compare z critical, we have two tests, right? Two tail tests. So then we are going to put two z values, right? We are going to have two z criticals, because two tails, right tail and left tail, both of them are going to be, one is going to be positive, one is going to be negative. Remember how we need to find critical value? We have significance level 0.1. It says here in the question 0.1. It's right here. 0.1 significance level. Since we have two tail, we are splitting this 0.1 and we are getting 0.05. So 0.05. 0.05, it's going to be less than 50%. So we are going to negative z-score table, right? Finding 0.05, and let's see how much will be our z-score. It's definitely we're going to find negative, and then for positive side we are going to flip the sign, right, and get the positive one. So let's find, you can get to your table, and I'm doing in my table. Be careful, it's usually words I also mess up sometimes, and so students also. There is only 1 0 after at the point, so be careful. So 0.05, that's all, not two of them, not two zeros there. 0.05, I have here close. Let me see. It's gonna be I found it's between 0.0505 and 0.0495, and that is negative 1.645, which is going to be negative 1.65 if we round up. So it's going to be plus minus 1.65. Let's try. Let's check it. So I guess we can put plus minus, huh? Do we have here plus minus? We do. Plus minus 1.65. Let's check. Incorrect. Why? How much is wrong? How many it wants? 3 decimals. Okay, if it wants 3 decimals, then 1.645. Because I rounded, it was between 1.64 and 1.65. So it should be 1.645. Nice work this time. Okay, so once we have it, so what's the conclusion we can draw? Let me see. Negative 2.25. So negative 1.65. Positive 1.65 and negative 2.25. Here it is. So it's falling in rejection area, right? Negative 2.25. So from here, we are stating that we reject null hypothesis, and since we reject, there is sufficient evidence, right, to reject null hypothesis, reject the claim, blah, 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 and then the politician's claim does not appear to have merit. Let's check. I will post this much, and then in next video I'll record the rest, next 9 questions, okay? Bye.